So this video will show problems 5, 6, and 7 on the 2019 Math Counts team competition. All right, let's go. I can't wait for number 5. Number 7 is pretty cool. So number 5, I don't love this explanation, so please forgive me. So the first thing that we know is we're going from we're going from San Antonio to Dallas.
How far is that?
It's kind of far. Texas is a big state.
Because it would be easier being how far it was.
And then, well, it doesn't really matter because then we drive straight back from Dallas back to San Antonio. And so the distance doesn't change. And we know that the rate that you're driving, the speed that you're driving, times time is equal to the distance. And so that's why we don't need to know how far it is, because the distances are equal. So I am going to talk about things as wholes and fractions of a whole. So we know that the speed that they're driving is going to be a one whole trip, right? Does that make sense so far? Then that means that this part of the trip here is broken into two parts. One part is the fast part and one part is the slow part. So if my average speed here is 1, then when I'm going fast, my fast speed is going to be 10% faster than I was going originally.
So
1 and 1/10 or 1.1. The part that I get stuck in traffic is going to be my 1 minus,
So 0.7.
it's going to be 0.7. So that's the first thing that I have to acknowledge. So then, what I really need to do is we need to figure out a ratio. So it's the question is asking, what fraction of the distance of her trip does she travel at the faster speed? So I'm looking for a fraction of a trip. So I know the answer is going to be less than 1, right?
So if she did more than 1, then
It'd be more than 1 trip, right? So what I need to do is, and we'll come back to this rate times time equals distance, I need to know how much or what fraction of the trip, what fraction of the time was she traveling at the fast speed, what fraction of time was she traveling at the slow speed. Well, that may seem ridiculous or tough, but there's a nice way of doing this. So her original speed is 1, right? And remember, we're looking for a fraction of of how much she was going the faster speed, right? So we're looking for a fraction. So the original speed is 1, right? And so the shortcut here is we can just subtract out the 70% of it, right?
yeah, and then you 3 left.
And so likewise, for the faster speed, that 1.1, we also can subtract out that 0.7. And that's going to tell us that we are going to be going 3/4 of the trip at the faster speed. So if I go 3/4 of the trip at the faster speed, what fraction of the trip will I go the slower speed?
1/4.
1/4. Okay, that makes sense.
But isn't it just asking
How far? What fraction of the distance?
Oh.
So this is telling me the time.
That's not 3/4 of the distance.
Right. This is 3/4 of the distance. Now I know the rate. I know the rate is 1.1 for the faster part, right? So my rate is 1.1. I'm going to multiply it. Well, 1.1, if I'm going to deal with a fraction of 3/2, it's going to be easier if I keep 1.1 as a fraction as well. So
1 and 1 for 11/10.
yeah, 11/10. So I'm going to keep that as 11/10. I'm going to multiply that by the time, which is right here, 3/4. So it's 3/4 of the time,
Equals 33/40.
33/40. Write it big over here.
Is that our answer?
hmm
Yay!
So the part that I find difficult in this problem, if I'm being entirely honest, is I'm trying to make sense of this piece here. And why does that? Why does that give you the fraction of time that you are driving this whole thing? So that is sort of the tricky part on it. But there you go. All right. I'm going to give a shout out here to Luke.
No,
Todd.
Alex actually figured this one out.
Alex figured this out too. Okay, good job, Alex. All right, so the way I want to think about this is on this column, 5 of my 6 are going to have chips on it, and so based on these here, where do those 5 chips have to fall? Well, odds are it's going to have to go here because we have the 5 comma the 5. This row has 4. This is going to have a chip on it. Likewise, for the same thinking, that one as well. The 3 most likely, yep, here as well. And so then this row and this row has an equally likely chance of having it on. So just for funsies, I'm going to put a little X here, or it's gonna go here, right? It's gonna go in one of those two. Now I'm going to use the same logic, and I'll get back to these in a second. Same logic for this column. So it's probably going to be here. Okay, that's an eraser. I want a highlighter. Here, 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 and then I'm stuck with these two. But wait a second. If I pick this one, then I have to pick this one over here. 22 plus 36 is 58. Or if I pick this one and this one, 34 plus 24 is also 58. So does it matter if I go 22 and 36 or 34 and 24?
No.
No, I'll get the same result.
That's nice.
That is super nice. So I'm just going to stick with what I have here because it doesn't matter one way or another. So then, using that same logic, let's go to the one with the. So right now I've completed these 2 columns.
Should we like cross them out so you don't get? Oh.
Yeah, I put the dots there so I don't do them again. So now let's go to the next largest column, 3. Well, 3 and 4, all right, okay. And there's another 4, all right. And so then, and there's a 3 and a 3 here. Well, I'm willing to bet the same thing is going to happen over here. It's going to happen here as well. It's either going to be one or the other, and then they're going to flip-flop. So, let's go with 17. Who doesn't love 17? So now, this row is filled up, and this column is also filled up. All right, so now I'm stuck with the 2s and the 1s. I don't love that so much. So let's go with the 3, or let's go with the 4s. Let's do the 4s. So 4 and 4. Well, I can either go 1 here or 1 here. Or, and same thing here, 1 here or 1 here. Well, that creates the same situation we had with these 4. So it doesn't really matter which one we pick because the sum of that combination is going to be the same. So for example, if I go here and here, 25 plus 8 is 33. 7 plus 26 is also 33. So it doesn't matter which combination I pick. It'll always be the same. So now that is all filled up. This one is also all filled up. So now let's deal with the 3. All right. So for the 3, probably not going to be in the 1. I'm going to use this leftover column for the 1. So, and both of these need another one. So let's go here. So that fills up this one and this one. And then finally, we have these 2's, and this 2 and that 1. Well, okay, let's just make it work. So that's 2. So now that's filled up, and this has 2 now, so that is all filled up as well. And that means my 1 has to go here. As luck would have it, I'm not going to do this now, but if you add up all of these,
326.
you get 326. Ta-da! All right, number 4.
7.
Sorry, number 7. All right, number 7 is a little bit longer of a problem, so you know what? I'm going to stop this, and I'm just going to do 7 and 8 on a different one.